So in this video, we are going to talk about mechanics. Under that, we are going to study what statics, right? So the word mechanics here, this one talks about what a movement, right? So let's say a movement. So we are trying to understand the basic concept of what we are going to do here. And then the static here is something that is at rest. So if you are saying this guy is at rest, meaning that you are not moving, right? So you are here. If you are here right now, so you are stable. Is that okay? This thing can be an object or maybe even this marker, right? So if you have placed this marker here or a board marker, right? So this whiteboard marker, if you have placed it here, it doesn't move, right? Is that okay? It doesn't move. So this is something that we are saying that this is a very stable, right? You are static, maybe you are at rest, you are not moving. But the key word is how can we apply the mechanics, the movement on this thing? So that one requires some forces. So if you are saying this is the force that I'm applying this thing, so with the help of my hand, that is the force that I'm applying to make it move up to a certain point of my own choice. Is that okay? So that is the concept of these two things. If you wish to know more about these concepts, make sure that you subscribe to the channel, give us a thumbs up, comment down below if you have any issue. Now let's have a look at a very pure exams question on how to deal with some of the questions relating to mechanics and under statics. Now, according to the question, we are told that a body of mass. So, the body of mass here, we are not talking about a human body. So, it can be any object you can think of. It's okay, anything that doesn't move, right? So, that's what we are referring to be what a body. Okay, now a body of mass. The mass of that body is 3 kilograms. So, assuming this is the body, right? So, this is the body. So, okay, for your advice now, I would advise you to, if you have a questions that are relating to a practical issues on this, I would advise you to draw it, right? So have a rough sketch on that. Is that okay? So this is the body of mass, 3 kilograms. So that's what the question is saying. So it's placed on what? Smooth plane inclined. So something that has what? It's not on the level ground, right? So it's small, something like this. So you can place that on top of anything. So this, assuming this is a smooth incline. So that's just a sketch. Something that is slanted in something like this, right? So a smooth incline. So this body is being placed on this a smooth incline with body. Remember that this is a level ground, right? So this is straight here will be the level ground. Is that okay? So maybe if I want to extend this one to this point, you can see that this thing can be what? The level ground, right? Can you see the picture? So this is just on the level ground here. So this is the level ground. Is that okay? So here everything here will be what? The level ground. So but there's another way. This thing can be a table. You can even think of this thing to be in the form of let's say if you attend this my small body in something like this. Once I place the marker on it, you can see that the marker goes down, right? So have you see? So that is exactly what we are talking about, right? So it goes down, right, until it falls. So that is very simple. So you place this body on what? An incline what? So it will come down, right? So this body will drop down like this. Is that okay? So now let's continue with the question. So here's the angle of what? At an angle of 40 degrees horizontally. So this is the horizontal. So that's the technical name, straightforward like this, right? So you can even think of the horizontal to be the level ground, right? So at an angle of what? 40 degrees, right? So this is the ground. So you have moved from the ground here to a certain point. Is that okay? So you raise your table. It can be maybe this thing can even be a ladder. But remember that I said that on the smooth plane, right? So smooth plane. Okay. Now, if you raise this thing on the level ground to the degree of 40, and then the body, the substance that you place on this plane ground is at 3 kilogram. Remember, what are they asking us to do? Now, they want us to find correct to one decimal place, the magnitude of the force required to keep the body in what equilibrium. So what that means is that we don't want this thing to fall down. Is that okay? We don't want this body to drop. That is the most important thing here. Now, they want us to know how what will be the force that we can apply on this thing, right? So there must be something, a force that will push what this object what upward, right? So push it or hold it there. That's the most important thing. They say it has to be in equilibrium, right? You don't want this thing to drop down or either goes up. I get to the point. So we need one force from this direction, right? So from here to to push these things in some way, right? So there's another force here that's all pushing this one up. Are you getting the point? So we need a force that we can apply on this body here so that it won't drop down, neither it will go up or it will raise up in some way, right? Something like this, or maybe it will come down in some senses. Are you getting the concept? Right, that's the most important. So other matters here, do we need a force that will help us to hold this thing in equilibrium? How do you determine that? Now you can see that this thing, if there's no force that is being applied on this object here, right? Which direction will this object drop? It will come down, right? So since it will come down, we need a force here, right? So a force here that can push or can hold it in equilibrium, can hold it at where it must be. Is okay. So the force will come from this direction. So technically, this will be the area. I don't want to go with the technical definitions here. This will be one force here, and then this will be the magnitude that cos theta, right? So and then this one will be the magnitude that sine was sine theta. It's okay. These are the technical definitions, but what I just explained are the red on something that you must clearly understand. So there is one force here that goes so in this direction of magnitude, right? So mass and the magnitude, that's the force. So everything that we are doing here are the force. But which force are exactly that you are supposed to apply on this object so that it will be on equilibrium? This force, right? So this is the force that we are looking for. So it is your duty to know exactly what this thing means. So this thing stands for, so this is the force that we are going to look for, because this is the only force that can help us to hold this thing in equilibrium. So we are pushing this thing upward, or we hold it in that equilibrium. So the force here, that was mg sine what? Sine theta. Is that okay? Mg, so the m here stands for the mass, right? So the mass, and this is the gravitational force, right? So the gravitational force was given to us from the question that should go 10 meters per second, right? So 10 meters, in some cases, that is 9.8, right? So here we are going to use 10 meters per second, and then the sine theta, the angle, the theta is the angle that they gave to us. So theta will be the angle at 40 degrees, right? So this is the angle. So we are giving all these things from the question. So what are you have to pay a closer attention? This is exactly force that we are looking for. Is that okay? So everything here that should be equal to, so here everything will be equal to, so you just need to place the numbers within this definition. Is that okay? So the mass here is what that was what the mass from the question, that was 3, and then multiply by this gravitational force, which was 10, and then the signs of the angle. So the angle that they gave to us was 40 degrees. That was what we were told that we raise our plane from the level ground, that's the horizontal ground, so we got 40 degrees, right? So now you need to solve this thing on your calculator. Remember, or maybe you can go straight for a sine if you know exactly what a sine 40 will be, right? So what sine 40 will be, so everything here will give me, according to my solution, that was your 9.8, right? So 9.8. Remember that the question said that write this thing to the key thing here, you have to know the unit of this thing. Remember, this is the force, right? So the unit of this thing, that should be what? Newton, right? So that should be what? A Newton. But remember, they say you should run this into what? One decimal place. Once again, if you enjoyed the video, don't forget to subscribe to the channel for more content. Give us a thumbs up if you really want us to see something like this in the near future. So we run this into the one decimal place to one decimal place, right? So one decimal place here, that should be 19.3, right? So 0.3 and so this is the force that we have to apply against this body so that we can hold it in equilibrium. So thanks for watching this.